Hello students, welcome to experiencetutor.com. Today we'll go through IIT Mathematics complex numbers.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Square root of negative numbers. Here, under root minus 1 is defined as I. It is pronounced as iota. Therefore, we can write I square is equal to minus 1 and IQ will be equal to minus I. I4 will be equal to 1. If A is a positive real number, then we can write under root minus A as A into minus 1, which can be again written as A into minus 1 root, and we can write it as under root A iota. Similarly, if if m is an integer, then we can write I for m, I to the power 4m is equal to 1, I to the power 4m I to the power 4m plus 1 is equal to I, and again I to the power 4m plus 2 plus 2 is equal to minus 1, and I to the power 4m plus 3 is equal to I. Minus the sum of any consecutive 4 powers of I is 0. For example, what we mean to say by this, for example, so you want to say that I to the power n plus I to the power n plus 1 plus I to the power n plus 2 plus I to the power n plus 3 is equal to 0. We can also write this as point number 3 as 1 upon I 1 upon I is equal to minus I, and 1 and minus 1 upon I is equal to
I. Now we have a question, find the value of I to the power 39. So we can write I to the power 39 as I to the power 36 plus 3 is equal to I to the power 4 into 9 into I to the power 3. We can write I to the power 4 into 9 as 1 because its power is multiple of 4 into I to the power 3 we can write as minus I. So in the next step we'll write so minus I. This is the answer. Now next question is find the value of y is equal to I plus I square plus I cube plus I to the power 4 plus dot 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 I to the power 100 plus I to the power 101. So we can write the same sum as y is equal to bracket I plus I square plus I cube plus I to the power 4 bracket close plus I 5 plus I 6 plus I 7 plus I 8 plus dot 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 dot. Again we can write it as I 97 plus I 98 plus I 99 plus I 100 plus I 101 which is equal to this whole will be equal to 0, this whole will be equal to 0, this whole will equal to 0 and again this will be equal to 0. So we'll get it as 0 plus 0 plus dot 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 0 plus I to the power 101. Now we can write it as I to the power 101 I to the power 101 can be written as I to the power 4 into 25 plus 1, which can again be written as I to the power 4 into 25 into I. So the value is 1 into I, which is equal to I. Here we have x is equal to 1 plus I. So we can write x minus 1 is equal to I. Therefore, in the equation x minus 1 to the power 4 plus 4, instead of this value we can write I. So I to the power 4 plus 4 will give I to the power 4 is 1 plus 4 will give 5. So this is the answer. Therefore, any number in the form of x plus iy is known as complex number, where x and y are real numbers and I is equal to under root minus 1. Therefore, a complex number z is equal to x plus I y, where x is the real part and y is the imaginary part. So if x is 0, then the complex number is purely imaginary. If y is 0, then the complex number is purely real. And if z is 0, the complex number is imaginary as well as real. A complex number can be represented in Argand plane, complex plane or Gaussian plane. In the figure you can see two axes, x and y axis, where x is the real axis, y is the imaginary axis. The complex number z can be represented in the figure as shown. Its coordinate p is xy. Its modulus of a complex number can be represented as OP. OP is equal to modulus of Z, which is equal to under root real part of square, that is x square, plus imaginary part of the square, that is y square. Now let us solve a small question regarding modulus. Find the modulus of z is equal to root 3 plus I. Here z is equal to root 3 plus I. Therefore real part x is equal to root 3 and the imaginary part y is equal to 1. Therefore modulus z if we write the formula, it will be x square plus y square under root, which is equal to root 3 square plus 1 square, which will give 3 plus 1, which is root 4, and which is equal to 2. Our next question is find the modulus of z is equal to x plus I under root 1 plus 2x, where x is a real number and x is less than equal to half. So we can write the sum as z is equal to x plus I to the power 1 minus 2x. So real part is x and imaginary part is 1 minus under root 1 minus 2x. So modulus of z we can write it as x square plus 1 minus 2x. Here root and square gets cancelled each other, so 1 minus 2x is left. Therefore it can be written as x square minus 2x plus 1, which is the formula of x minus 1's whole square. So the value is mod x minus 1, which is the answer. Now let us know what is an argument of a complex number. If z is a complex number which is equal to x plus iy, then argument of the complex number is the angle which the line joining the number represented in the argand plane to the origin makes with the positive x-axis or positive real axis. Therefore, we can write as in the given figure, theta is the angle made with the real x-axis. Then OP, the length of OP from origin to O to P to the point P is x square plus y square root. Now argument cos theta will be x upon under root x square plus y square based upon hypotenuse according to Pythagoras theorem. Sin theta will be y upon x square plus y square. The argument of z is also called amplitude of z. The argument of any point lying in the interval minus pi is called principal argument. Rules to find out principal argument. If z is equal to x plus iy is a complex number where x and y are non-zero real numbers, then and theta is equal to tan inverse y by x, then first rule is argument z is equal to theta, argument z will be equal to theta when x will be greater than 0 and y will be greater than equal to 0. Y will be greater than equal to 0. Next point, argument z will be equal to pi minus theta. Pi minus theta when if x is smaller than 0 and y is greater than equal to 0. Here the point lies in the first quadrant. First quadrant. Here the point lies in the second quadrant. Quadrant. Third rule is argument z is equal to theta minus pi. If x is less than 0, y is less than 0. And y is less than 0. Here point lies in the third quadrant. Last one is argument z is equal to minus theta. If x is greater than 0, y is less than 0. And y is less than 0. Here the point lies in the fourth quadrant. One more rule is there. It has, if we mark it as 1, then the second rule is argument of 0 plus argument of 0 plus 0 I or I0 is equal to not defined. We can't define this value. So our question is, find the principal argument of all complex numbers represented by plus minus 1 plus minus I. In this case, we have 4 points. One plus I minus 1 plus I minus 1 minus I and plus 1 and plus 1 minus I. Minus I. Now tan theta is equal to, we can write tan theta is equal to modulus y upon x is equal to 1, which implies that theta is equal to pi by 4. Therefore, therefore we can write argument of 1 plus I is equal to theta is equal to pi by 4. It will fall in the first quadrant. According to the next rule of argument, we can write argument minus 1 plus I is equal to pi minus theta is equal to pi minus pi by 4, which is equal to 3 pi by 4, which will fall in the second quadrant. According to the third rule of argument, we can write argument of minus 1 minus I as theta minus pi, which is equal to pi by 4 minus pi, which will give a result of minus 3 pi by 4, which will fall in the third quadrant. The fourth argument will be argument of 1 minus I, which is equal to minus theta, which is equal to minus pi by 4. This will fall in the fourth quadrant. Our next question is, if z is equal to x plus iy, then find the value of argument of modulus z. So, as we know that z is modulus z, so we know that modulus of z is greater than or equal to 0. If modulus of z is greater than 0, then argument of z is equal to 0. Then argument of z will be equal to 0. If again in the next case, if modulus of z is equal to 0, then argument of z cannot be defined. Is not defined. Now our next question is, find the sum of argument of 1 plus argument of 2i plus argument of minus I plus argument of minus 1. So argument of 1 is equal to argument of 1 is equal to 0. Argument of minus I argument of minus 1 is equal to pi. Argument of 2i is equal to pi by 2. Argument of minus I is equal to minus pi by 2. Therefore, the sum will be equal to 0 plus pi plus pi by 2 minus pi by 2. So it will be equal to, on solving this, will be equal to pi.